Hello everyone. In this class we will discuss very important questions from ray optics which is already asked in the many exams. So this is helpful for your competitive exams like NEET and all, and also useful for your school level exam. So look at with the first question. Which of the following is used in optical fibers? So in optical fiber is nothing but the application of TIR, which is nothing but total internal reflection. So look at the next question. If two mirrors are kept at 60 degree to each other, then the number of images formed by them is. So number of images formed, formula we have 360 upon theta minus 1. So angle is given 60 degree. So 360 upon 60, which is nothing but 6 6 are, so 6 minus 1, which is 5. So total number of images is formed 5. Look at the next important question. So the question is, a light ray is incident perpendicular to one of the face of 90 degree prism and totally internally reflected in the glass air interface. If the angle of reflection is 45 degree, we can conclude that refractive index n is. Okay. So if you look at this question, diagram is and light is entering perpendicular to the glass of prism. So whenever ray of light entering perpendicular to the surface, it always going without deflection. That means the angle of incidence is 0 here, and angle of refraction is also 0 whenever light is entering perpendicular. After that it is striking here, and the angle of reflection is given 45 degree. Okay, because it is given that it is totally internal reflected in this surface. So it is given that angle of reflection is here 45 degree. Okay, so if this angle is 45 degree, then this angle is also 45 and this angle is also 45. Okay, because this is 90 degree, so we can easily calculate these two angles are 45. Now if we apply here, it is total internal reflection is going on. So when we get total internal reflection, whenever our angle of incidence must be greater than critical angle IC. So if we multiply both the side by sine, so sine I must be greater than sine of angle critical IC. Okay, so sine I, now angle of critical angle formula we have sine IC or sine I critical angle is equal to 1 upon mu. This is the formula in terms of refractive index of critical angle. So if I apply here, it will be 1 upon mu. So we have to find out this mu only. Okay, so if I take this mu here and sine I here, so we'll get mu is greater than 1 upon sine I. So at what angle this ray directly, okay, this refraction angle is nothing but here, for this surface it is incident. Okay, so the angle of incidence for this surface is 45 degree, which is given. So mu is greater than 1 upon sine 45 degree. And we know that sine 45, which is nothing but 1 by root 2. So 1 upon root 2. So the denominator of the denominator will go in the numerator. So we'll get mu is greater than root 2. So the correct answer is here option number B. Mu means n, refractive index n, which is greater than root 2. Okay, look at the next question. So this is a very interesting question from Snell's law. So given that refractive index of the transparent cylinder rod is 2 upon root 3. Refractive index mu is given. So figure is also given. The question is an incident at midpoint of this one of the end, for which angle of incidence, means we have to find out that I, angle of incidence I, which is given here theta. The ray become parallel to the end of the rod. Okay, like this here. Parallel to the rod means the refraction is 90 degree here. Okay. So let's call, we have to find out this theta, that is our aim. So let's call this angle is, refraction angle is alpha, and here the angle is beta. And this beta is nothing but critical angle actually. Okay. So at this both the position, one is here, one this point, and the second point is here. So at the first position we will apply the Snell's law. Okay. So Snell's law is nothing but sine angle of incidence, which is nothing but here theta. So sine theta upon sine angle of refraction, so that we have taken as alpha, so upon sine alpha is equal to mu 2 by mu 1. So mu 2 means in which light is entering, which is nothing but given by 2 by root 3. So 2 upon root 3 divided by mu1. Mu1 means from where light ray is coming. So that is from air. So refractive index of air is 1. So upon 1 is same thing, 2 by root 3. So we'll get our first equation, sin theta upon sin alpha is equal to 2 by root 3. Then if you can see that here this is nothing but light is going parallel to the surface. That means this beta is a critical angle. Okay. Otherwise, if you apply the Snell's law, that is also fine. So sin beta, according to Snell's law, sin beta upon sin 90 degree is equal to, we'll get mu2 by mu1. So mu2, it is going in the air after that. So mu2 is 1, and mu1, which is nothing but refractive index of the material, that is 2 by root 3. So 2 upon root 3. So that upon root 3 will go in the numerator. So sin beta upon sin 90 is 1 is equal to, we'll get root 3 by 2. So sin beta upon 1 means sin beta only, which is given by is equal to root 3 by 2. So here sin beta is there, and which is root 3 by 2. So at what angle sin is root 3 by 2? Sin 60 degree. That means this beta value must be 60 degree. So we got the value of beta, that is nothing but 60. Now if you look at this triangle carefully, okay, beta is here. If I draw this line and if I make the triangle, so this is right angle triangle. In this beta angle, we know beta angle is 60 degree. Okay, if I make this triangle properly here our alpha is there, here beta, which is 60 degree, and this is 90 degree. So if you apply angle sum property, so we know that angle total angle in the triangle is 180 degree. So this is 90, this is 60. So the remaining angle is what? 90 plus 60, which is 150. So the remaining angle is 30 degree. Okay, because total must be 180. So alpha value is nothing but 30 degree. So if I place the alpha value in first equation, then we will get sin theta upon alpha is 30. So sin 30 is nothing but 1 by 2 is equal to 2 upon root 3. So if you multiply this 1 by 2 here cross, we will get sin theta is equal to 2 upon root 3 multiplied by 1 upon 2. So this 2 and 2 will get cancelled. So we will get sin theta is equal to 1 upon root 3. So we have to find out what theta. So theta is equal to, if we take sin this side, it becomes sin inverse of 1 upon root 3. Okay, so our correct answer is theta is equal to sin inverse of 1 by root 3. Option number A. Look at the next question. This is also important question. A fish looking up through a water sees outside the world contained in a circular horizon. If the refractive index of the water is given 1.4 by 3 and the fish is 12 centimeter below the water surface, the radius of the circle is, you have to find out radius r. Okay, so whenever this type of question will come, you have to just look at one short trick. Okay, so look at the diagram. Fish is below 12 centimeter from the water surface, so that depth is given d 12 centimeter. So fish is looking upward. So how much it can see maximum? It can see like this in circular region. Okay, whenever we can from our eyes also maximum view we can see like a circular. So we have to find out the radius. Okay, so whenever like this question will come, that inside the water surface some object is there, so how much that can see on the top of the surface, and find out the radius of that. So that formula of that radius, you can remember, r is equal to d upon root of n square minus 1. D means that depth, n is nothing but refractive index. So in our question the depth is given 12. Okay, this is the formula that we have to apply. Short trick, you have to remember, r is equal to d upon root of n square minus 1. So depth, that is given to be 12 upon root of n. N is refractive index, which is given 4 by 3. So 4 by 3 the whole square, which is 16 by 9 minus 1. So if we do the cross multiplication, 12 upon root of 16 minus 9 is 9 upon 9. So 16 minus 9, which is nothing but 7. So root 7 by 9. So root 7 we cannot find out, but root of 9, which is nothing but 3. So denominator of the denominator will go in the numerator. So 12 3s are 36 upon root 7. So the correct answer is 36 by root 7, option number D. Look at the next question. The question is, two lenses of power minus 15 diopter and plus 5 diopter are in contact with each other. The focal length of the combination is, so two powers are given, minus 5, minus 15 and plus 5. So power of the combination is nothing but P1 plus P2. Okay, and we have to find out the focal length of the combination. So power is nothing but 1 by f, reciprocal of focal length. P1 is minus 15, P2 is plus 5. So minus 15 plus 5, which is nothing but minus 10. Okay, so 1 upon f is equal to minus 10. So if we take the reciprocal, we will get f is equal to minus 1 by 10. But it is in meter, which is focal length. Okay, we have to, if we convert in terms of centimeter, 1 meter means 100 centimeter. So 100 by 10, which is nothing but minus 10 centimeter, because we want answer in centimeter. So the correct answer is C, minus 10 centimeter. Look at the next one. Look at the next important question. A monochromatic light is incident on a glass prism at angle A, of a glass prism of angle A. If the refractive index of the material of prism is mu, and the ray of incident at an angle theta. Okay, so it is incident angle is given theta on the face AB would get transmitted through the face AC of the prism provided. Okay, so the question is saying at what angle theta this incident ray must come such that it will get transmitted through this surface AC outside. Okay, so that theta we have to find out. It must be greater than of this, less than, greater than cos inverse or sin inverse. Okay, so to get that ray transmitted through the face AC, it satisfies this condition must. For transmission, R2 must be less than, okay, look at this ray diagram. To get transmitted from this surface AC, okay, here the, let's say this is incident angle theta. After the incidence angle theta, here it is theta, let's say this is refractive index, refraction angle R1, and here refraction angle is R2. We have to get outside of this face AC. Okay, so R1 is refraction angle first one, and this R2 is the second refraction angle. So to get transmitted through the face AC, our angle of incidence must be, okay, we have to get outside. If I draw properly, this is normal ray, here the angle R2, and we have to come back outside through this surface AC. That means our angle of incidence, this is R2 is nothing but in this case angle of incidence. So that R2 must be less than critical angle, correct? If that angle is more than critical angle, then it will be come back in the same medium, then TR will happen. But we don't want TR, we have to get transmitted through this surface AC outside. That means that angle must be less than the critical angle. Okay, so this condition is must be satisfied. Now if we apply both the side by sine, so it becomes sine R2 is less than sine IC. Okay, but we know that R2 in this prism, we know that R1 plus R2 is equal to A. This condition is satisfied. So from here we can say R2 is nothing but A minus R1. Okay, so if we apply this here, we will get sine R2 is nothing but A minus R1 is less than, here it is sine IC, means critical angle. So we know that critical angle formula sine IC is same as 1 upon mu. Okay, now if I take this sine that side, it become A minus R1 is equal to, not is equal to, less than sine inverse of 1 upon mu. Okay, somehow we have to convert this full thing in terms of theta. We want theta, so theta is here. Okay, so we have to convert in terms of theta. So we'll find out this R1 first. Okay, so if I take this A value that side, it will get minus R1 is equal to, not is equal to, less than sine inverse of 1 upon mu minus A. But here minus R1 is there, so we want plus. So if I change the sign, so R1 is become plus. So if we change the sign, this inequality will reverse. Less than become greater than, and this minus A become plus A, and this sine inverse become minus sine inverse 1 upon mu. Okay, if we change the sign, the equality will reverse. Now R1. Okay, so if we take both the side by sine, so we'll get sine R1 is greater than sine of this full thing inside the bracket, a minus sine 1 upon mu. Okay, both the side we have taken sine multiplied by sine. Now we know that the Snell's law, if we apply the Snell's law at the starting position, what we will get from the Snell's law? Sine theta upon sine R1 is equal to mu2 by mu1, correct? So mu2 is the refractive index of the prism is given mu upon mu1, that is air, so refractive index is 1. So if you do the cross multiplication, we will get sine theta is equal to mu times sine R1. Okay, so from here if you find out the value of sine R1 is nothing but sine theta upon mu is equal to sine R1. So that value we have to substitute here. Sine R1 means sine theta upon mu, which is greater than sine bracket a minus sine 1 upon mu. So if we multiply this mu here, we will get sine theta is greater than mu times sine this full thing inside the bracket. Now we want this theta only. So if we take this sine that side, we will get theta which is greater than sine inverse inside the bracket this full thing, mu times sine, and inside the bracket a minus sine 1 by mu. So this is our answer. Theta must be greater than sine inverse mu times sine 1 minus a minus sine mu by 2. So if we look at our option, we will get the answer is A. Theta must be greater than sine inverse mu times sine a minus sine inverse of 1 by mu. Okay. Look at the next question. The next question is, a telescope has magnification is equal to phi. So m is given phi. Length of its tube is given to be 60. L is given 60. The focal length of its eyepiece is. Okay. So to find out that focal length of eyepiece, we'll use the formula of magnification first. So m is equal to FO upon FE. So magnification, which is given phi, is equal to FO upon FE. So if we do the cross multiplication here, we'll get FO is equal to phi times FE. Now we'll use this second length formula. So length of this telescope is given by L is equal to FO plus FE. So length is given 60. So 60 is equal to FO. So the value of FO is phi times FE plus FE. So phi FE plus FE, which is nothing but 6 times FE, is equal to 60. So if we take this 6 in the denominator, so 60 by 6 is equal to FE. That means 60 by 6, which is nothing but 10. So the focal length of eyepiece is 10 centimeter. Look at the next question. So the next question is, a plano-convex lens of radius of curvature 30 centimeter. So radius is given and refractive index is given 1.5 kept in air. That means we'll consider mu2 is equal to 1 in this case. Mu1 finds its focal length. Okay, so we have the lens maker formula 1 by f is equal to mu minus 1. Okay, whenever it is kept in air, we'll consider mu minus 1 only. Inside the bracket 1 by r1 minus 1 by r2. Now look at the lens which is given plano-convex. So one side it is a plane. So one radius of curvature will take infinity. Okay, because for plane lens the radius of curvature is infinity. And second radius is given 30 centimeter. Okay, you can take first or second, it doesn't matter. So R2 is, will take minus 30 centimeter. Okay, from the right side. Refractive index is given 1.5. Okay. Here in the middle minus sign is there, so to deal with this minus sign we'll take here minus 30. So 1 by f is equal to refractive index is given 1.5 minus 1 inside the bracket 1 upon r1, which is infinity, minus 1 upon r2, which is 30. So minus minus become plus 30. So 1 by infinity, which is 0, 1.5 minus 1, which is 0.5, multiply by 1 by 30. So 0.5, which is nothing but 1 by 2 into 1 by 30, that is 1 by 60. And this side we have 1 by f. So if we take the reciprocal, we'll get focal length f to be 60 centimeter. Okay, so correct answer is B, 60. Look at the next one. Look at the next one. The focal length of a lens whose refractive index is same as that of outside the medium. Okay, now in this case, lens is not kept in air. It is given the refractive index of inside and outside both are same. That means mu2 and mu1 both are same. So we'll apply the lens maker formula, our main formula, 1 by f is equal to, now we'll write mu2 by mu1 minus 1 into 1 by r1 plus minus 1 by r2. But what is the main thing is given, mu2 and mu1 both are same. So if I apply here mu2 and mu1 both are same, so if the same quantity will divide, the answer must be 1. Okay, so mu2 and mu1 is same, so both will get cancelled, so answer is 1. So 1 minus 1, which is 0, and 0 into this full bracket will be 0. So we are getting 1 upon f is equal to 0. So 1 upon f is equal to 0, that means f is equal to infinity. So the correct answer is C. Look at the next question. Look at the next important question. Which of the following color pass through the prism? That is the question. Okay, refractive index of blue light, green light and red light is given. And one more thing is given, that angle of prism, let's say it is given to be A, which is 45 degree. So which light out of these three will pass through the prism? Okay, so if we look at this ray, it is entering perpendicular to the surface. Okay, so that will enter directly straight. After that, if we draw here normal line, then for green line also, and for red line. So we know that this angle of prism is 45, then the incidence angle here, that is also 45. Similarly here also 45 and here also 45 degree. Okay, this is a maths, simple maths. Whenever light enters perpendicularly, then it will make the same angle whatever is here with the angle of prism as a angle of incidence. So if angle of prism is 45, then this angle is also 45, this is also 45, this is also 45. Okay, now if we want to find out which ray will cross the prism, means pass through the prism. So which ray, which light won't be passed through the prism, that means when TR will happen, that we'll see. So if our angle of incidence means I is greater than critical angle, in that case TR will happen. It will reflect in the same medium. Okay, so we'll find that condition first. So if I apply both the side by sine, so sine I must be greater than sine critical angle IC. So sine I means incident angle, which is nothing but 45 degree for all the rays. So sine 45 is greater than, now we know that the formula of sine IC in terms of refractive index, which is nothing but 1 upon mu. And sine 45, that value is 1 by root 2, greater than 1 upon mu. So if we do the cross multiplication, so mu must be greater than root 2. We are getting this condition. Okay, and here all equal to is also there. Angle of incidence must be greater than equal to critical angle, so is equal to is also there. So mu must be greater than equal to root 2. Root 2 means 1.41 approx value. So whenever the refractive index is more than 4.14 or equal to, in that case light must reflected back in the same medium. So look at the first refractive index of blue light, which is 1.41. So 1.49, which is greater than 1.41. So blue light will get TIR. Okay, so it won't get passed through the prism, it will bend inside the same medium. After that, green light, the refractive index is 1.41, which is also equal to 1.41 equal to 1.41. Okay, so it is on the border, is equal to is there, so that light also come outside, it will bend inside only, so it will get TIR. But if you look at the refractive index of red light, which is 1.27, so it is not greater than 1.41, which is less. So red light will come outside the prism, so it will pass through the prism. So the correct answer is C, red light will pass through the prism. Okay. Look at the next question. Look at one more important question. Two slabs of the same thickness of 6 cm each are placed over one other, shown in the figure. Okay, so both have a same thickness, 6 cm, 6 cm, and refractive index of both the plates are given 7 by 3 and 5 by 3. So we have to find out apparent depth of the table surface is n centimeters, so that we have to find out that n in terms of integer. Okay, so whenever like this question will come, that two bodies of the thickness are given, are placed over one over another, and we have to find out that apparent depth. In that case we have the formula, okay, for virtual depth, not apparent depth. Virtual depth is equal to T1 upon mu1 plus T2 upon mu2, direct formula. Okay, so T1 and T2 are the thickness, mu1 and mu2 are the refractive index of the first and second slab. So T1, that is 6 upon refractive index of that is 7 by 3. So 6 upon 7 upon 3 will go in the numerator, plus T2, which is also 6 upon refractive index is 5 upon 3. So upon 3 will go in the numerator. Okay, so 6 is 18, here also 18, so 18 will come common outside. So inside the bracket 1 by 7 plus 1 by 5. So 18 into, if we do the cross multiplication, so 7 plus 5 upon 7 into 5. So 18 into 12 upon 35. So if we solve that, we'll get approximately 6.17. So the nearby, which integer is there? 6.17. The closest integer value nearby is nothing but 6. So the correct answer is 6 for this question. Look at the next question. Look at the next important question. Equiconvex lens cut into two different ways shown in the figure. Okay, so in the first figure we are cutting the lens in this part, like this, from the middle. So upper part is lens L1, lower part is lens L2. The second lens we are cutting like this, in this way. So this is length L3 and L4. So the question is asking, what is the value of L1 upon L2? So remember the result, when you are cutting the lens in this manner, in that case focal length is same, whatever is given as it is. There is no change in focal length and power, it will remain same as it is. But when we cut in this manner, in that case, suppose the original focal length is f, so if we cut, then the focal length of this part and focal length of the remaining part, it will be double, so 2f and 2f. So if the focal length is double, in that case power is half. Okay, so the question is, what is the value of L1 upon L3? So for the first part, L1, the focal length is remain same, f, and for L3, that is a second part, we are cutting in like this. So in that case focal length is double, 2f. So the ratio L1 by L3, which is nothing but f upon 2f. So f will get cancelled, so answer is 1 by 2. So the correct answer is C for this question. Look at the next part. The next question is directly based on the formula. The question is, minimum deviation prism having refractive index mu and small angle of prism A is given by. Okay, so this formula we don't have. Here theta is given, this is wrong. Here plus sign is given, this is wrong. So this is the correct answer. Minimum deviation is equal to mu minus 1 times angle of prism A. Look at the next question. A point source light is placed 4 meter below water surface. In the medium having the refractive index 5 by 3, a disc is placed on the water surface such that it blocks the light coming out of the water completely. So minimum diameter of the disc is, okay, so one object is placed below 4 meter in the depth. Here a disc is given on the surface such that it will block the light. Okay, so we have to find out the diameter. So for this type of question, I have given the one short trick formula to find out the radius. Okay, so radius, how to find? The formula is the depth which below the object is placed upon root of mu square minus 1, refractive index the whole square minus 1. So depth is given 4 meter upon root of mu square, so mu is given 5 upon 3, so 5 upon 3 the whole square minus 1. So if we solve this, we'll get 4 upon root of 5 square, which is 25, upon 3 square, which is 9 minus 1. So if we do the cross multiplication in the denominator, so 4 upon root of 25 minus 9 ones are 9 upon 9. So 4 upon root of 25 minus 9, which is 16 by 9. So root of 16, which is 4, root of 9, which is 3. So denominator of the denominator will go in the numerator. So we'll get 4 upon 4 multiplied by 3. So this 4 and 4 will get cancelled. So radius is nothing but 3. But we want diameter. So radius is 3. In that case, diameter is nothing but 6. Diameter is double of radius, 2 times r. So 2 times 3, which is nothing but 6. So the correct answer is 6 for this question. Look at the next question. Next question, a bioconvex lens is cut into in such a way that equal two halves, first in XOX days and second YO dash. Okay, so this is a lens. First part we are cutting like this and second part we are cutting like this. So what is the focal length? Original focal length is f, and f dash is the focal length of the first case. Okay, means when we are cutting this lens like this, then whatever focal length we will get of the new part, that is f dash, and whenever we are cutting like this vertically, that focal length is given by f double dash. So just now we have seen the result. Whenever we are cutting the lens horizontally, in that case the new focal length is same as original, and when we are cutting vertically, in that case the new focal length is doubled the original. So the correct answer for this question is B1. F dash is equal to same f, and f double dash is nothing but double. Look at the next one. Next question, a combination is formed by keeping a convex lens in contact with concave lens. Okay, so two lenses are in contact, one is convex and one is concave. So we know that focal length of convex is positive and focal length of concave is negative. If both have a same focal length of 25, so focal length is also same, in that case the net focal length combination is 0, because 1 upon 25 and 1 is 1 upon 25, but one is positive, one is negative, so the total answer is 0. But answer is 0 of what? 1 upon f, answer is 0. Okay, so 1 upon f is nothing but power p, so we have to find out that power only. So focal 1 upon f is 0, so that means power is also 0. Okay, so in this case power is 0, but if the question is what is focal length, so focal length is infinity. Okay, because 1 upon f value is 0, so f is infinity, power is 0. So correct answer is C, 0. Look at the next question. A coin is at rest at the bottom of the tank filled with a liquid. A ray of light coming towards the surface with a move on the surface after incident of it. Then what is the speed of light in liquid? Okay, so this figure is given. The depth of the coin from the water surface is given 4 centimeter, and after, okay, here normal ray is there, this is the incident angle, and after getting refracted, it is moving like this. So that means this angle is 90 degree. Okay, in that case this angle is nothing but critical angle. So if you look at this diagram properly, this depth is given 4 centimeter and this is given 3 centimeter. So this is nothing but right angle triangle, and if you look at the triplets, this is 3, this is 4, so in that case this wavelength is nothing but 5 centimeter by using triplets value. Okay, and this angle is nothing but critical angle, because here the refraction is 90 degree. So if you apply the refraction angle critical angle formula, that is sine IC is equal to 1 upon mu. So sine critical angle, that we don't know, okay, and 1 upon mu refractive index, which is, okay, refractive index is not given. So refractive index how to find? So here one trick is there, why this triangle is given and this 3 and 4 value is given, that is the important thing. So this value is given 4, this value is given 3, so this value I said it is 5 by using triplet value, or you can apply the Pythagoras theorem. Okay, now we know that here it is angle of incidence I. Okay, and this is a surface base, so these two lines are parallel, water surface and this base surface. So between this parallel, this is nothing but transversal line. Okay, so that means whatever angle is here, the same angle must be here. So this angle is also I, and this is nothing but critical angle IC, so this is also critical angle IC. Okay, this is called alternate interior angle. So this is a right angle triangle. If I apply here sine IC, so we know that sine is nothing but opposite upon hypotenuse. Okay, so opposite is 3 and hypotenuse value is nothing but 5. So if I substitute the value here, sine IC, which is nothing but 3 by 5, so we will get 3 by 5 is equal to 1 upon mu. So if we take the reciprocal, we will get mu is equal to 5 over 3. Okay, so from this triangle we got the refractive index, which is 5 by 3. Now we have to find out speed of light. in this medium liquid. So formula we have mu is equal to C upon V. So we have to find out this V. So we will take V here and mu here. So V is equal to C upon mu. So V is equal to C, which is nothing but 3 into 10 raised to 8 upon mu, which is nothing but 5 upon 3. So upon 3 will go in the numerator. So 3 3s are 9. So 9 upon 5 multiply by 10 raised to 8. So 10 raised to 8 is there in every option. Okay, so no need to do anything. We have to just solve what is 9 upon 5. So when we divide 9 upon 5, the first digit will get 1 because 5 ones are 5, correct? So that means this option is wrong, this is wrong. So two options is right, remaining 1.2 and 1.8. So if we solve further, remainder is 4. Then if we take 0, so 5 8 is 40. So answer is 1.8. Look at the next question. Look at the next question. The question is, a ray of light travels in the medium of refractive index mu. It incidents at a surface in contact with air. Okay, so air is given, so we will take refractive index of the first medium is 1. At 45 degree, what value of mu this ray will undergo total internal reflection? So to do TIR, we have one condition, that is the angle of incidence I must be greater than critical angle IC. Okay, so if you apply both the side by sine, so we will get sine I is greater than sine of IC. Okay, that means sine of incidence angle I must be greater than or equal to, okay, equal to is also there here. Sine, okay, sine IC means the formula is nothing but in terms of refractive index, which is 1 upon mu. Okay. So what is angle of incidence given? Angle of incidence given is 45 degree. So if you apply here, we'll get sine 45 is greater than equal to 1 upon mu. So sine 45, which is 1 by root 2, greater than equal to 1 by mu. So if we do the cross multiplication, so mu into 1 mu greater than equal to root 2 into 1 root 2. That means the refractive index of mu must be greater than equal to root 2. Root 2 is nothing but 1.41. So which value is there 1.41 greater than of that? The first is 1.33, which is less than, wrong. Second is 1.40, which is also wrong. 1.50, yes, this is greater than 1.41. So in this case we will get TIR. Okay, here also we won't get TIR. So correct answer is C. Look at the next question. The question is, which of the following phenomenon does not depend on the TIR? So optical fiber, it is a part of TIR, so this is wrong. Real and apparent depth of vessel filled with water, so yes, this is not a part of TIR. Remaining mirage formation, that is also TIR part, and sparklium diamond, that is also application of TIR. Okay, so this is not phenomenon of TIR. Look at the next question. The angle of prism is A. One of its refracting surface is silvered. Light ray falling on the angle of incidence 2A. Okay, so angle of incidence is given I 2A. So light is going inside and it is coming back on the same path, okay, from this silvered surface. So the question is, what is the formula of refractive index? So if you look at this diagram properly, incidence angle is given I is equal to 2A. Okay, now light is going inside, so let's say this is a refraction angle R. So it is going, and after refraction it is coming back. That means the angle of refraction, that is R2, okay, refraction is here, R2 is nothing but 0, because there is no refraction at this silvered surface. So R2 is 0, and this angle, first refraction is, let's say, R1. Now we have a condition in the prism, A is equal to nothing but R1 plus R2. So R2 is 0, R1 we don't know, and angle of prism is given A. So that means A is same as R1. So we got one condition, that is A is same as R1. So if we apply the Snell's law here, sine of incidence angle I upon sine R is equal to mu2 by mu1. Okay, so mu1 is nothing but 1 because it is air. So sine I is given refractive incidence angle, that is 2A. Sine 2A upon sine R1 here. R means R1 here. So R1 is same as what? A. So sine A is equal to refractive index of this prism, means mu. So sine 2A upon sine A. Okay, so in the option we need the answer okay without fraction. So if you apply the formula of sine to a, okay, in the maths we have formula sine to theta is nothing but 2 sine theta into cos theta. This is the formula of sine to theta. So we have here sine 2a. So sine 2a means 2 sine a into cos a. And in the denominator we have 1 sine a. So this sine a will get cancelled. So our answer is 2 times cos a. That is the value of refractive index mu. So the correct answer is B, 2 cos a. Look at the next question. Look at this next question. If the focal length of objective lens is increased, okay, that means FO is increased, in that case magnifying power of, so magnifying power of microscope and telescope both we have to see. So the magnification power of microscope formula is given by LD upon FO into FE. So in that case objective lens focal length and microscope power, that is inverse relation, magnification power and focal length of object, inverse relation. So if FO increases, magnification decreases in case of microscope, and for telescope the formula is FO upon FE. So here magnification and focal length of object lens is direct relation. So FO increases, magnification is also increases power. So for microscope magnification decreases, for telescope magnification increases. So the correct answer is microscope decreases magnification power and for telescope it is increases. So correct answer is D. Look at the next one. Look at the next question. These two columns are given. We have to match these two columns with magnification and according to their images in concave and convex mirror. So look at the result first. For concave mirror, when the magnification is negative, the image is formed real and inverted, and for magnification is positive, in that case image is virtual and erect. And for convex mirror, the magnification is always positive and the image is formed virtual and erect. Now look at the matching. So the first magnification is negative, so concave mirror is never possible, so A will never come with A. So 1 is A, so option number A is wrong, B is also wrong because 1 is with A, that is not correct. After that, so for negative, so if you look at the result, magnification is negative, in that case image is real and inverted. Okay, so mirror is concave plus real image, so 1 with B and C. So option number D is correct, C is also wrong. Remaining option also you can verify. For negative, the mirror is concave mirror and real image, so again B and C. And for third, magnification is positive, so if magnification is positive, in that case convex mirror is also there, but with positive magnification image is virtual. Okay, so answer is A with D. So in the option, none of the option A with D is there, so we will take concave mirror, positive magnification with virtual image. So concave means B with D, so that is there, so option number D is the correct answer. Okay, look at the next one. Look at the next question. The angle of incidence for a ray of light of a refracting surface of prism is 45 degree. So I is given 45 degree and angle of prism is given 60 degree. A is equal to 60. So the question is, the ray suffers minimum deviation, so that means delta m is there through the prism. So the angle of minimum deviation delta m we have to find out and refractive index mu we have to find out. So whenever it bends, minimum deviation is there, in that case we know that I is same as E and R1 is same as R2. So we'll apply the formula of bending, that 2I is equal to A plus delta m to find out minimum deviation. So angle of incidence, which is given 45, is equal to angle of prism, which is 60 plus delta m. So 2 into 45, which is 90, and if you take this 60 this side, become minus 960 is equal to delta m. So angle of minimum deviation, which is 90 minus 60, that is 30. So option number D is wrong, option number B is wrong. Now option number A and C is remaining. Now we have to find out refractive index mu. So if you apply the formula of refractive index, mu is equal to sine A plus delta m upon 2 upon sine A by 2. So we will get sine A is 60 plus minimum deviation, which is 30, and upon 2, whole divided by sine A is 60 upon 2. So 60 plus 30, which is 90, 90 by 2, which is 45. So in the numerator sine 45, and in the denominator 60 by 2, which is 30, so sine 30. So sine 45, which is 1 by root 2, and sine 30, okay, so 1 by root 2 upon sine 30, which is 1 by 2. So if we take the reciprocal of the denominator, we have to multiply with the numerator. So 1 by root 2 multiply by 2 by 1. So this 2 can be written as root 2 into root 2. So 1 root 2 will get cancelled, so answer is root 2. So refractive index is root 2. So our correct option is option number A. Refractive index is root 2 and minimum deviation is 30 degree. Look at the next question. Next question, based on the very simple formula, angle of prism is given A 60 degree, angle of minimum deviation is given delta m 40 degree, and then angle of refraction we have to find out. So whenever the deviation is minimum, in that case we know that R1 is equal to R2, and we have one equation, A is equal to R1 plus R2. So in that case A is nothing but 2 times R. So we have to find out this R, so R is nothing but A upon 2. So angle of prism, which is given to be 60, so if we divide by 2, we will get 30 degree angle of refraction. So correct answer is B. Look at the next one. The next question is, the refractive index of material prism is given root 2, angle of prism is given 30 degree. One of the surface is made by silver coating. So you can see that figure is given like this. So beam of light entering the prism for other face will retrace its path. Okay. So the question is, we have to find out incidence angle of the prism. That means this eye angle we have to find out. So light is going like this, okay, then it is striking on this surface wherever silver coating is there, and after striking it is coming back to the same path. Okay, that means at this angle there is no refraction, that means R2 is 0. Okay, if you see this diagram, there are two refraction here. Okay, one is angle of refraction is here R1, and other refraction is here R2. So whenever light is coming back on the same path, in that case refraction is 0. Okay, so R2 is 0 here. So we have to find out R1. Okay, so I told you one short trick, whenever light is coming back like this, in that case this angle and this angle both are same, because if you look at the triangle properly, okay, here it is 90 degree because it is striking perpendicular. So this is 90 and this angle is given 30. So 90 plus 30, 120. So the remaining angle is 60. But we want this angle. So this ray is normal. So total is 90. So the remaining angle is 30. That means this angle must be exactly equal to this refraction angle R. Okay. Otherwise, by using this formula also we can find out. We know that A is equal to R1 plus R2. Okay. So whenever it is coming back with the same path, in that case there is no refraction. That means R2 is equal to 0. Plus R1 we have to find out, and angle of prism is given already 30. So that means R1 is nothing but same as angle of prism, which is 30. Now we'll apply the Snell's law to find out angle of incidence I. Okay. So Snell's law is what? Sine angle of incidence, which is given, okay, that we have to find out, upon sine refraction angle, that is nothing but 30. So sine 30 is equal to mu 2. Mu 2 means refractive index of the prism, which is given to be root 2, upon mu 1. So light is coming from the air, so refractive index of air is 1. So if we do the cross multiplication here, so sine I is equal to root 2 times sine 30. Sine 30 is 1 by 2. Okay, so root 2 multiplied by 1 upon 2. 2 can be written as root 2 into root 2. So 1 root 2 will get cancelled. So we will get 1 upon root 2. So at what angle sine is 1 by root 2? That is our incidence angle I. So we know that sine is 1 by root 2 at 45 degree. So correct answer is D, 45. Look at the next question. Look at the next question. A ray of light incident and angle of incidence I on the surface of small angle prism with angle of prism A and emerges normally from the opposite surface. So if the refractive index is mu, then angle of incidence will be nearly equal to what? Okay. So remember some tricks to solve this type of question. In most of the question, whenever light is entering like that, incidence angle I, here refraction angle is R, and on this second surface, whenever it is falling on perpendicular, okay, so either it is retracing its path or it is going outside normally. So in both the case, remember this result. The first result is angle of prism is same as r1, okay. Refraction angle at second surface is 0 because it is normal to that surface, okay. So if you apply the result, r1 plus r2 is equal to a, so we are getting a is equal to r1. The second result is angle of incidence. Directly you can remember that is same as mu times r1, okay, and r1 is nothing but same as a, so other result we can say I is nothing but mu times a, okay. So these are the results. So in this question we have to find out angle of incidence. So angle of incidence is nothing but mu times a. So correct answer is B, mu times a. So if you know this result, then you can solve the question in a short time in your exam. Okay. Look at the next question. Next question, find the value of angle of emergence from this prism. Refractive index of the glass is given √3. Okay, so mu is given the √3. We have to find out angle of emergence. So emergence means here. Okay, so if I draw the normal line, so normal line is like this, perpendicular to the surface. So we have to find out this angle, emergence E. So first of all, if you apply the short trick here, this angle is 30, which is given. So if this angle is 30, so in that case this angle is also 30 degree. Okay. So if you apply the Snell's law at this position, so sine 30 upon sine E is equal to outside refractive index, which is air, so 1, upon inside refractive index, which is glass, so √3. So if you do the cross multiplication, sine 30 multiplied by √3 is equal to sine E. So sine 30, which is 1 by 2, so 1 by 2 into √3 is equal to sine E. So 1 by 2 into √3, which is nothing but √3 by 2 is equal to sine E. So at what angle sine value is √3 by 2? At 60 degree angle. So that means the value of E must be 60 degree. So angle of emergence is 60 degrees. So correct answer is B, 60. Look at the next question. The next question is a convex lens A of focal length 20 and concave lens B of focal length 5 cm are kept along the same axis with a distance d between them if parallel beam of light falling on A leaves B as a parallel beam. Okay, that means the net focal length will be infinity. The distance we have to find out d between them, focal lenses. So whenever two lenses are there, one is let's say convex and other can be convex, concave, anything. Okay, so like this it is there, they are separated by some distance. So that distance d we have to find out. Okay, so the equivalent focal length whenever two lenses are separated by some distance d is given by like this: 1 by f is equal to 1 by f1 plus 1 by f2 minus d upon f1 f2. Okay, this is in general formula. After that we have to take the sign convention of focal length f1, that is convex lens, so it is plus 20. f2 is a focal length of concave lens, so it is minus 5. Okay, this negative sign we have not used here, this is the in general formula. And equivalent focal length is nothing but infinity because of the it is going parallel only. So if you apply these values here, so 1 upon f is equivalent focal length, so that is 1 by infinity is equal to 1 upon 20 plus 1 upon minus 5 minus d upon 20 into minus 5. So 1 by infinity, which is 0, is equal to 1 upon 20 plus minus minus 1 upon 5, then this minus, and if you multiply 20 into 5, so 20 into 5, which is nothing but minus 100. So minus minus getting plus d by 100. Okay, so if we do the cross multiplication here, we will get 5 minus 20 upon 100 plus d upon 100. So if we take this d upon 100 that side, it become minus d by 100 is equal to, and this side minus 15 by 100. So this 100 will get cancelled, minus sign will get cancelled, so the value of d is nothing but 15 centimeter. Okay, so the distance between two lenses is 15 centimeter, which is correct option is C. Look at the next question. Look at the next question. In a certain camera, a combination of 4 similar thin convex lenses are arranged axially in contact. Then the power of combination and total magnification in comparison to the power P and magnification M for each lens will be respectively. Okay, so total 4 convex lenses are there, 1, 2, 3, 4. They are kept in a contact with the magnification m1, m2, m3, m4. So let's say magnification of each is given to be m, and the power of each lens is given to be p for each lens. Same power, same magnification. Then what is the total power and total magnification? That is the question. So to find out the power when the lenses are in contact, we have the formula P1 plus P2 plus P3 plus P4. We have to just simply add. So power of each lens is equal, let's say P, then P plus P plus P plus P, which is nothing but 4 times P. So power, equivalent power is 4 times P, and to find out the equivalent magnification, we are multiplying. So m1 into m2 into m2 into m3. So magnification of each lens, let's say, equal to be m, then m multiplied by m multiplied by m multiplied by m, which is same as m to the power 4. Okay, so remember, magnification we have to multiply always, and power we have to add up to find out equivalent. So the correct answer here is power is 4p and magnification is m raised to power 4. Look at the next question. A microscope has objective focal length 2 cm, eyepiece focal length 4 cm, tube length is 40, and the distance of distinct vision of the eye is 25. The magnification of the microscope is. Okay. So for compound microscope, the magnification formula is given by m is equal to LD upon FO into FE. So length is given 40, D is given 25, FO is given 2, F is given 4. So if we put all this value, we will get 40 into 25 upon 2 into 4. So 4 tens are 40, 2 5s are 10. So 25 into 5, which is nothing but 125. So answer is 125, which is option number A. Look at the next one. The question is, a substance in liquid dipped in liquid, then due to which region substance will be visible? Not visible. The question is, due to which region the substance will be invisible? Okay, the question is here, invisible. Due to which region? So when the substance will be invisible when we dipped in a liquid, only one condition, whenever the refractive index of that substance and the liquid are same. If the refractive index of both this thing is same, in that case that substance, if we dipped inside, then it become invisible. Okay, because there is no refraction, so no light will come. So whenever the refractive index are same for the substance and the liquid, it become invisible. So correct answer is D. Look at the next question. Here it is. This is invisible. Okay. Next question. Light ray bends when travels from one medium to another medium. Because why it is bending? Because its speed is changing. So correct answer is speed is changing. Look at the next question. The magnifying power of telescope is m. If the focal length of the eyepiece is half, then the magnifying power is. So we know that the formula of magnifying power of the telescope is m is equal to FO upon FE. So magnifying power and eyepiece focal length is inversely related. So if eyepiece focal length is halved, okay, so FE become FE by 2. So in that case magnification is doubled, means m becomes 2m, double. Because it is inversely related, so focal length is half, so magnification is doubled, so it is 2m. Otherwise you can solve by using the formula, you will get the answer same. Look at the next question. The question is, focal length of thin lens of refractive index 1.5 is 15 cm. When placed on liquid, the refractive index is 4/3, then its focal length will be. Okay, so one thin lens is there, refractive index of thin lens is given 1.5 and the focal length is given 15, and when it is placed in liquid of refractive index 1.4/3, we have to find out the focal length. So we have one short trick result, that focal length in liquid of the thin lens is approximately 4 times focal length in air. Okay, in the liquid focal length increases as compared to in air, but this result you can apply only whenever the refractive index is standard 1.5, 4/3, okay, for standard glass. So focal length of thin lens in liquid is nothing but 4 times focal length in air. So in the air, what is the focal length? 15 cm. So 4 times 15, which is nothing but 60. So correct answer is D, 60 centimeter. Okay. Look at the next question. The next question, a lens of refractive index 1.5 is placed in a liquid. To make it disappear, the value of n of the liquid should be. Okay, so we have just seen the result. Whenever we have to make the substance to be disappear, we have to make the refractive index to be equal of that liquid and that substance. So the lens, refractive index of the lens is given 1.5, and to make it disappear lens, we have to keep the refractive index of liquid is also 1.5, exactly same. So the correct answer is B. Look at the next one. The next question is a lens of power -4 diopter. It means, okay, so power is given negative. That means it is nothing but concave. We'll get the focal length is concave. So option number C, convex, that is wrong. Option D, that is convex, wrong. Okay, power is negative means it must be concave lens. Now we have to find out the focal length. So we have the formula P is equal to 1 over F. So power is given -4, but the unit will be diopter, so it is meter inverse, but we want answer in centimeter. Okay, so if we do the change, F will come here, -4 will come here, so F is equal to 1 by -4, and we have to convert in terms of centimeter, so we will divide by 100. So 4 is here, so upon 100 means you have to divide that 100 in the numerator. So 100 by 4, which is nothing but -25 centimeter. So correct answer is A, concave lens of focal length -25 centimeter. Look at the next question. Theory based question. The amount of ray length scattering is, so the amount of ray length scattering light is directly proportional to 1 upon lambda raised to 4, or you can say inversely proportional to the lambda raised to power 4. Okay, so the answer is C, inversely proportional to the 4th power of wavelength, means lambda. Look at the next one. Double lenses are to be manufactured from a glass of refractive index 1.5 with both faces of the same radius of curvature r, then the focal length of f is. Okay, so remember the result. Whenever double lenses are given, we have to manufacture from a glass of refractive index 1.5, and both the lenses have the same radius of curvature. In this case, the focal length is also same as radius. Okay, r and f both are equal in this case whenever the radius are given to be same and the refractive index given to be 1.5. So the correct answer is B. Otherwise you can solve by using the lens maker formula. You will get the same answer, r is equal to f. Okay, thank you very much.